What if your electricity didn't come from a power plant down the road, but from a satellite 400 miles above your head? Not a distant dream, not a sci-fi plot. Right now, some of the smartest and richest people on Earth are dead serious about making this happen. And at the center of it all, SpaceX. Elon Musk said publicly, on stage with Jensen Huang from NVIDIA right next to him, that perhaps in the 4 or 5 year time frame, the lowest cost way to do AI computing will be with solar-powered satellites in orbit. That's not a wild tweet, that's a business plan. So today, can SpaceX actually launch satellites that collect sunlight in space and beam energy back to Earth? How would it work? What's in the way? And how close are we? Really? Buckle up. This one is wild. This idea is older than you think. Back in 1968, engineer Peter Glaser wrote it all down, put giant solar panels in space, collect sunlight 24 hours a day, and beam that energy back to Earth using microwaves or lasers. Why space? No clouds, no night, no seasons. Sunlight up there is about 8 times more intense than what reaches the ground, and it never stops. NASA took it seriously in the 1970s during the oil crisis. The concept was promising, but the cost was enormous. It got shelved for decades. Fast forward to today, launch costs have dropped over 90% thanks to reusable rockets. Satellites are being mass-produced, and the world is hungry for clean, always-on energy. Suddenly the old dream doesn't look so crazy, and SpaceX, they're not just watching, they're building. To understand Power Starlink, you first need to understand what regular Starlink already is. Right now, over 7,000 Starlink satellites circle the planet at around 340 miles up, with tens of thousands more approved. Each one has solar panels and laser links to talk to its neighbors. No ground station needed. Here's what most people miss. SpaceX didn't just build an internet service. They built the world's first mass-produced satellite network. Cheap, fast, and replaceable. Now imagine upgrading those satellites. Bigger solar panels. And instead of beaming internet signals, they beam power. That's Power Starlink, in a nutshell. Musk has even put numbers on it. Using Starship and capable of carrying over 100 metric tons to orbit. He's talked about launching enough solar satellites to generate 100 to 500 gigawatts. For reference, the entire United States averages about 500 gigawatts. He's talking about powering a country from space. You can't run an extension cord from orbit, so engineers use one of 2 methods, microwaves or lasers. Microwaves are the most proven. The satellite converts solar energy into a microwave beam, and a ground antenna, called a rectenna, catches it and converts it back to electricity. Microwaves pass right through clouds and rain, and by the time the beam reaches the ground, it's actually less intense than direct sunlight. And it's not just theory. In 2023, Caltech became the first team to successfully beam solar power from space to a receiver on a building in California. Japan's JAXA went further, beaming 1 kilowatt of power to a ground station. Enough to run a coffee maker. Small, but proof it works in real space conditions. The second option is lasers. Tighter beam, smaller receiver. But clouds can block them. And a high-powered laser has obvious safety concerns if it drifts off target. Either way, the precision required is jaw-dropping. The satellite moves at over 17,000 miles per hour, and the beam has to stay locked on target with an error of less than 0.001 degrees. Modern systems include automatic shutoffs if anything enters the beam's path. But getting regulators comfortable with all of this remains a major challenge. Here's where it gets interesting and a little blurry. Musk hasn't officially announced a Power Starlink program, but if you're paying attention, what he has done is almost more significant. He's been saying the same things at multiple events in front of some of the most powerful people in the world. At a tech summit with NVIDIA's Jensen Huang and Saudi Arabia's communications minister, he said solar-powered satellites could become the cheapest way to do AI computing within 4 to 5 years. At the US-Saudi Investment Forum, he got more specific. Starship could deliver 300 to 500 gigawatts of solar satellite capacity into orbit every single year, not total, per year. He called it fully planned out and very crazy. What Musk is describing is a hybrid concept, not just power for Earth, but solar-powered data centers in orbit, satellites with solar panels and computer chips, running AI calculations in space. The energy never has to come down, but the core technology is the same either way. Massive solar arrays, cheap reusable launches, a constellation working together. Whether the power stays in orbit or gets beamed to Earth, SpaceX is building the infrastructure that makes both possible. Morgan Stanley took notice. When SpaceX was valued at $800 billion in late 2024, analysts said the market was already pricing in orbital data centers and orbital power as a major future business. We've been optimistic. Let's be honest. The challenges are enormous. Cost. NASA's 2024 report estimated a working space solar power station needs at least $275 billion upfront, with electricity costing 12 to 80 times more than ground-based power. Even with cheaper launches, we're still putting millions of tons of hardware into orbit. Scale. A meaningful system needs solar arrays several kilometers wide. The entire International Space Station's solar panels cover about 2,500 square meters. We'd need thousands of times more, built in space by robots, using technology we don't fully have yet. Beam precision. To steer a microwave beam efficiently, thousands of transmitter elements have to sync with timing errors measured in picoseconds, a trillionth of a second. At gigawatt scale, across an antenna a kilometer wide, this has engineers genuinely stumped. Crowded orbit. There are already 15,000 satellites up there. Massive solar satellites in geosynchronous orbit would share space with GPS, defense, and communication satellites. Managing that without collisions is a regulatory and engineering nightmare. End of life. A solar satellite the size of a small city eventually needs to come down or be replaced. There's currently no good plan for safely deorbiting something that large. These aren't reasons to give up. But serious engineers say a real grid-scale system is realistically a 2040s or 2050s project, even in the most optimistic scenarios. SpaceX isn't alone. Japan's JAXA has been the most advanced in actual testing, including that successful power beaming demonstration we mentioned, backed by a formal roadmap decades in the making. The UK government concluded space-based solar power is technically feasible and could be commercially competitive by the 2040s. China is moving aggressively, with ground tests already underway and ambitions to have a working demonstration in orbit before 2030. In the private sector, StarCloud, backed by Y Combinator, Andreessen Horowitz, and Sequoia, is already in orbit. In December 2025, they completed the world's first AI model training done entirely in space. That happened. Google, Amazon, and Axiom Space are all exploring versions of this too. The race isn't just between countries, it's between the richest companies on the planet. Here's the honest answer. Space-based power is almost certainly coming. The question is not if, it's when, and who gets there first. The pieces are falling into place faster than anyone expected. Starship is flying. Launch costs are dropping. The first power beaming tests have succeeded. Investment is flowing in, but we're not replacing coal plants by 2030. The engineering challenges are real. The costs are real. The regulatory battles haven't even started. What's more likely in the next 5 to 10 years is a hybrid path. Solar satellites, first power, AI data centers in orbit, proving the technology at scale. Then, as costs drop, power starts coming back to Earth. Musk has talked about building toward a Type 2 civilization, one that captures the full energy output of its star. Today, humanity uses about 0.000000001% of the sun's energy. Orbital Power Grid isn't just an energy project. It's the first step toward that. Outro. And that's the Orbital Power Grid, a 50-year-old dream that SpaceX, almost by accident, while building something else, is finally giving us the tools to build. If you want to stay ahead of stories like this before they hit the mainstream, subscribe. This one's going to be everywhere soon. Do you think Musk can actually pull this off? drop it in the comments. See you in the next one.